press the bell icon on the YouTube app and never miss another update.
Hello my dear students, we started the surface chemistry. In that we discuss about the introduction to the surface chemistry, then what is adsorption, desorption, and mechanism of adsorption, right? And with that let us move on to the next concept in this chapter, that is types of adsorption. I think I already given the headings. Types, if you take, the first one is physical adsorption. Okay, that is also called as physisorption. The second one is chemical adsorption. So that is also called as chemisorption, right? So these are the two types of adsorption. So let us discuss one by one, and you should know that on what basis these two are classified. So based on the type of interactions between the adsorbent and the adsorbate. So you have to recall again. So you know the meaning of that adsorbate and adsorbent, right? Adsorbate is nothing but the gas or the liquid which is undergoing the adsorption. What is that? Bate is nothing but the substance which is going the adsorption, and bent is nothing but the surface on which, usually it is solid, on the surface of which the adsorption is going to be happen, right? So now based on the type of interaction between the adsorbate and the adsorbent, it has been classified into two types. The first one, if you take the first type of this adsorption, that is physical adsorption, that is also called as Physisorption. So the phenomenon in which adsorbate molecules are held to the adsorbent surface. See, adsorbent surface by weak van der Waals forces of attraction. By weak van der Waals forces. So that's why, as they are the physical forces, weak van der Waals forces, that's why it is called as physisorption or physical adsorption, right? Understood the definition? Here the adsorbate molecules are held to the, or attached to the, or adsorbed to the surface of the adsorbent by means of van der Waals force of attraction. So now if you give an example for this type, we can have chlorine on animal charcoal, or any gas you can have that it is adsorbed on the surface of the animal charcoal by means of what forces? Van der Waals forces of attraction. That's why it is an example for physisorption, or you can say the physical adsorption, right? So now what are the characteristic features of this physical absorption? Characteristics. Okay, what are the characteristics feature of this adsorption? So the first one is nothing but lack of specificity. So what is this? So as this, what is that? Physical adsorption involve van der Waals forces, and you know about van der Waals forces. These are universal. Van der Waals. Yes, van der Waals forces are universal. that means to say universal, it means to say any gas that forms these forces undergo what? Physical adsorption. Undergo physical adsorption, or you can say physisorption. Whatever it may be the gas, because they are the weak forces of attraction, they are present in almost all the compounds. What is that? There is a meaning of the word universal. So that's why any gas which forms these forces will undergo physisorption. That's why it is not specific. It is not specific because you are using the term any gas. It is not fixed, right? Any gas which forms van der Waals forces will undergo physisorption. That is called as lack of specificity, or you can say it is non-specific in nature. Like that also you can say the difference. If you move on to the next one, that is, let me rub this one. The next difference, if you take, that is nature of adsorbate. Nature of adsorbate. So you know the meaning of adsorbate, the one which is undergoing adsorption. It may be gas or the liquid which will get adsorbed on the surface of the adsorbent, right? So here now, so it was found that easily liquefiable gases possess high intermolecular forces. With high critical temperature. So already learned this one, right? That is in the first PUC. Critical temperature, that is the maximum temperature at which the liquid state of a gas exists, right? Beyond this there will be no liquid, or below this there will be no liquid. So that is the critical temperature. So higher the critical temperature, higher will be the intermolecular force of attraction, right? More easily it will undergo adsorption. So that's why easily liquefiable gases possess high intermolecular forces with high critical temperature, easily undergo physisorption. That is the next point, physisorption. We can have an example for this one. They have given very good example for this one. So if you take, you are having mixture of gases like sulfur dioxide, then methane, then they have given dihydrogen. So the order of adsorption will be like this. Sulfur dioxide will be more easily liquefiable than methane, which is more liquefiable than the hydrogen. If you want the values, yes, just I can give the values of critical temperature. That is for this one, it is 630 critical temperature. How you are going to represent? TC, right? 630 Kelvin, it comes around 190 Kelvin, and then if you take this one, it is just 33 Kelvin. Okay, so this is the order of adsorption. So higher the critical temperature, higher will be the rate of adsorption. So out of these gases, which will be get easily adsorbed? Sulfur dioxide. Why? Because it is having higher intermolecular force of attraction because of its highest critical temperature. Are you getting the concept? So yes, that is the second difference. Then if you move on to the next one, or you can say next characteristic of this physisorption is that it is reversible in nature. It is third one, right? Reversible in nature. So how you are going to represent this adsorption, right? So you can have a gas which is found to be adsorbed on the surface of a solid. So it leads to the formation of a gas solid interface plus heat. As you know that reverse, that is adsorptions are usually what? Exothermic in nature. Adsorptions are highly exothermic in nature. So higher the pressure readily takes place, when pressure decreases, desorption takes place. Like that the concept is. So look at the reaction here. So gas plus solid gives rise to gas solid. So gas has been adsorbed on the surface of the solid. So then what happens to the pressure? If you apply more pressure on low, then only the gas will adsorb on the surface of the solid. Right. So once the pressure decreases, what happens? The volume increases. Pressure decreases means volume increases. Then you can see that will be desorption, the removal of the adsorbed molecule from the surface. Right. You can easily, as these reactions are exothermic in nature, because plus heat means you can represent delta H is equal to minus negative. Minus. What is the meaning of that? These are exothermic in nature and they can be reversed at any stage. Or you can say the reason this one also. Why it is reversible in nature? Because the gas adsorbs on the surface of the solid by means of weak van der Waals forces of attraction, so that we can easily reverse the reaction. So it is reversible in nature. Okay na? So next characteristic if you want to have, so that is nothing but the surface area. What is the next point? Surface area. So how it affects our physical adsorption, right? Surface area. So you know that as the surface area increases, the rate of adsorption increases. As the surface area increases, the rate of adsorption increases. Because you know that if the surface area is more, then what happens? There will be availability of more space for the adsorption of the gas. So we can quote one point here. The catalyst will be highly active in its finely divided state. Very important concept this is. The catalyst is highly active in its finely divided state. Why? Because of the availability of more surface area, more reactant will bind to that, more products will be formed. Like that here. So as the surface area increases, so in number of interactions of gas with the solid increases. So that's why rate of adsorption also increases. Very important point this is. Next, if you move on to the next point or next characteristics of this what we can say physisorption, that is enthalpy of adsorption. So that I can write here. The enthalpy of adsorption is is having a value of 20 to 40 kilojoules. Yes, 20 to 40 kilojoules per mole. It is a very having low enthalpy of adsorption. Very low enthalpy of adsorption. So you know that adsorption or exothermic. That means to say there is a release of energy. How much energy will be released? Very less amount of energy. Why? Because they are having weak van der Waals forces of attraction. Because of the weak forces, we can say that for physical adsorption or for physisorption, enthalpy of adsorption is low. So what you can say? Enthalpy of adsorption is very low. How much? That is nearly 20 to 40 kilojoules per mole. So, are you getting this one? What is the cause for this much low enthalpy of ionization? Enthalpy of adsorption. It is mainly because of weak van der Waals forces of attraction. Weak van der Waals forces. Because of this, so they are having low enthalpy of adsorption. Likewise, so here one more thing you can have, so that is effect of temperature if you take. So lower temperature favors physisorption. Okay, so because of, again the reason is van der Waals forces, because if you increase the temperature, no, so what happens? The adsorbate will dissolve from the surface of the adsorbent as this kinetic energy increases. So if they want to retain on the surface of the adsorbent, there should be what? Temperature should be low. So these are the important characteristic features of what? The physisorption. So likewise we are having one more, that is nothing but the chemisorption, or you can say that one as chemical adsorption. So what is that? So very simple concept, and what are the characteristics of that? Let us discuss now. Okay, so what is the next concept? The second type is nothing but the chemical adsorption. Chemical adsorption, or you can also say this one as what? Chemisorption, right? So what is this? The type of adsorption, or you can say the phenomenon in which adsorbate is held on the surface of adsorbent by means of strong chemical bonds. Let me write the definition. The phenomenon in which adsorbate, same definition, just you have to change the type of interactions, right? Adsorbate is held, yes, on the surface of what? Adsorbent, right? By strong chemical bonds, right? So those chemical bonds may be covalent bonds, or that may be the ionic bond. That depends on the type of the gas, or you can say the adsorbent and the adsorbate. So understood the definition? The phenomenon in which adsorbate is held on the surface of adsorbent by strong, yes, chemical bonds is called as chemisorption. Can you make out the difference? You have to list out the difference now. You have to compare the chemisorption with the physisorption. Thereby you are going to learn a 3 marks question. This is an important theory question. Mention any 3 differences between physisorption and chemisorption. They are going to ask. Then you should know, right? So you are reading the characteristics as well as simultaneously you have to list out the differences between physisorption and chemisorption. Are you getting? Yes. Now let me give an example for this one. That is physisorption. Sorry, that is chemisorption. You can have, that is adsorption of oxygen on metal surfaces, Only the oxygen will attach to the metal surfaces when it form oxides. Because in oxides only there is a presence of strong chemical bonds, right? This is one example. What example I have given for chemisorption? Sorry, physisorption, that is adsorption of chlorine gases on animal charcoal. That is example. Yes, understood the example? Next, if you move on to the characteristics of this, this chemisorption, if you take the first one, likewise I am going to write here, that is lack of specificity, right? It is highly specific in nature. What is that? So this chemisorption is highly specific in nature. That means to say, what is the meaning of this? So only the adsorbate which forms chemical bonds with the adsorbent will form or will undergo what? Chemisorption. That is not like that, right? That was not like that. Chemical adsorption or chemisorption, right? So that was not like that. Whatever it may be the gas that can form van der Waals forces, because van der Waals forces are universal, so that will adsorb on the surface of that adsorbent. But here it is not the case. Only the gases which form strong bonds with the adsorbent will undergo the chemisorption or chemical adsorption. Okay, so what was the next point we discussed there? That is nothing but nature of adsorbent. Nature of adsorbate. So here again I can repeat the same. So adsorbate means that is the gas which form chemical bonds. Only chemical bonds will undergo what? There is a that is chemisorption. Likewise, you can have the next one, that is nothing but the third one. So what is that? That is nothing but the reversible nature. That is reversible. It is irreversible. Irreversible in nature. Yes, chemical adsorption is irreversible in nature. Right? If you take solid plus gas, it gives rise to solid. That is a gas solid interface. It is also what? Exothermic only, but you can see that it is irreversible in nature because the gas held on the surface of the solid by means of strong chemical bonds, so that reversing the reaction require more energy as well as it happens at very high temperature. So the reaction is irreversible in nature. I hope you understood that concept. Next one, irreversible. After knowing this one irreversible nature, if you move on to the next one, that is surface area. Surface area, right? So if you take the surface area, it is similar to your Physisorption. So what is the meaning of that? As the surface area increases, increases what? Chemisorption also increases. Chemisorption also increases because of the availability of more space, more number of adsorbate molecule will be get adsorbed on the surface of what? That is nothing but the adsorbent. Yes, are you getting? So next one, fifth one. So if you take the enthalpy of adsorption, enthalpy of adsorption if you take, so that enthalpy of adsorption is very high. So that is of the order 80 to 240 kilojoules per mole, because the gas is adsorbed on the surface of solid by means of what? Strong chemical bonds. So to break that, so during the breaking of that one, large amount of energy is released, right? So that's why enthalpy of adsorption is very, very high because of the strong chemical bonds. So what is the order of that energy? It is nearly 80 to 240 kilojoules per mole. Yes. Next, if you move on to the effect of temperature, or you can say the characteristics, that is temperature, how it affects means, so it takes place at higher temperature, or you can say higher temperature favors chemisorption. So that means to say it increases with the increase in the temperature. Yes. So that is all about the characteristics of what? Your chemisorption, or you can say the chemical adsorption. So from this only we can list out the differences between Physisorption and chemisorption. Physisorption and chemisorption. Okay, this is important again, children. That is what differences between Physisorption and chemisorption. Okay, so just you can list out the differences. Again, one important concept this is. So if you have The first one is physical adsorption. I will write that one as physisorption. And then the second one is nothing but the chemisorption. So what are the characteristics I told just now? No, I explained just now. So you have to list out those, right, into the differences. So let us take up the first one. So what you are going to give the difference for this one? That is nothing but, yes, it is caused due to van der Waals forces of attraction. Van der Waals forces, right? So what you can write here? Yes, it caused or it is caused due to strong, yes, chemical bonds, right? That is a first difference. Second point, if you take, it is what? Reversible in nature. Reversible in nature. If you write reversible, that is enough. Right? So what you can write here, I am not going to explain again because I already explained the characteristics, just I am going to list out. Right? So what is that? It is irreversible in nature. Right? So next point, that is nothing but, to take that one, what is that? It is a non-specific. It is highly specific. I already explained this one, right? Highly specific. Yes, 3 marks, 1 to 3 is an absolutely very easy. Van der Waals forces, reversible, non-specific. Strong chemical bonds, irreversible, highly specific. But you should know more. Thereby, forget anyone, you can have that one. That is low, what? Enthalpy of. Low enthalpy of. What is that? Yes, adsorption. Right? Yes, children, what is the value? 22. Yes. 40 kilojoules per mole. Very good. 22, 40 kilojoules per mole. That is very low enthalpy of what? Adsorption. Sorry. Likewise, you can quote the difference here. What is the point you can give? Yes, high enthalpy of. What is that? Adsorption. High enthalpy of adsorption. Yes, what is that value? Yes, recall. 82. What's 240 kilojoules per mole. Very good. You should learn like this only. Very easy. You should think that while listening to the concept only, you have to take 3 marks into your package. Right? So what is that? So very simple to remember. Van der Waals forces, reversible, non-specific, low enthalpy of adsorption. Yes, strong chemical bonds, irreversible, highly specific. If you know this one, no, you can easily write down the opposite of that one. Right? So next, what is that? Low temperature. These are very important. What I have written from the top. 4, they are very important. Then you go for this one. What is that? Low, it favors low temperature. Low temperature favors what? Physisorption. Low temperature favors what? Physisorption. Likewise, what you can write? It increases with increase in temperature. That's why what you have to write? High temperature favors chemisorption. High temperature favors chemisorption. This is the point you can quote here. Okay, so likewise, one more you have to note down here. What is that? It forms, that is physisorption. I think I didn't explain. It forms multi-molecular layer. Yes, what is that? I will explain. Next, here it forms monomolecular layer. Monomolecular or unimolecular, you can represent it, forms monomolecular layer. Monomolecular layer. So what is the meaning of this? So if you take the adsorbent, right, and if you add the adsorbate, so if you, this one, that is the physical adsorption, means you are going to get like this. Do you know why? Because the adsorbate molecules are held on the surface of the adsorbent by means of weak forces. Those can enter, they can hold this one because they are weak. But if you take the what? Chemical adsorption, it is the adsorbent, then it forms like this. Do you know why? Because they are held by means of strong chemical bonds. The strong chemical bonds exist only between this layer and the adsorbent, not here. They cannot penetrate. They are not having any effect on the next one. They are highly specific in nature. Once they have absorbed, they will not absorb any other gases further. Okay na? So that is the meaning of what? So monomolecular layer and uni, or you can say mono layer, multimolecular and monomolecular layer. And one more point you can, it needs energy of activation. It needs energy of activation. Okay, it do not, or you can say it do not require any activation, or you can say energy of activation. So to start the physisorption, there should be activation because they are very poor forces of attraction. So that's why they need activation, but they are chemical bonds, that's why there should not be any activation. So this is one more important concept you have to remember. So these are very important, very easy to remember also. These are very important. Then you can go for others. They are what you can say, additional, right? They are very important. The question will come only for 3 marks, and it may possible only for 2 marks, not for 4 marks, 5 marks like that. Okay, yes, this is the differences. These are the differences between what? Physisorption and chemisorption. Okay now let us move on to the next concept. Yes students, shall I go? Yes, very little we covered. Okay, so what is that? One more very important concept for exam, that is adsorption. Isotherms. Adsorption isotherms. So you have to recall isotherms. If writing means, should go for your states of matter, what you learn in your first PUC. Isotherms. Yes, they are the graphs where there is a temperature is constant. Temperature remains constant, right? So what is that isotherms, or what is this adsorption isotherms means? So it is a mathematical expression. Let me give the definition. A mathematical expression. Mathematical expression. Let me give the bookish definition, or graphical representation also. It may be the graphical representation. Okay, which relates, or that relates amount of a gas, adsorb on the adsorbent at constant temperature and the equilibrium pressure. So this is the definition for this adsorption isotherms. Yes, I will repeat. The mathematical expression or graphical representation that relates amount of a gas adsorbed on the surface of adsorbent at constant temperature and the equilibrium pressure. Right. So there are two types of this adsorption isotherms. One is Freundlich adsorption isotherm, and one more is there, that is nothing but Langmuir adsorption isotherm. Okay, so we are going to discuss the first one in detail because that is there in your NCERT textbook, but it is not there in the NCERT textbook. Just I will give a brief information of this Langmuir adsorption isotherm. Are you getting? Yes, let us discuss the first one, that is, so understood the meaning of this adsorption isotherm? That is just a graph, or you can say that is just a formula or expression where we can see the presence of what amount of gas adsorbed and the mass of the adsorbent and the pressure and the temperature. Right. So that is first one, Freundlich adsorption isotherm. So let me write here the first one. Yes, let me begin from this one, thereby we can cover up the whole concept. Yes, what is that? Freundlich adsorption isotherm. Okay, na? Yes. So what is this again? So Freundlich, that is the name of the scientist. In 1909 derived okay, an empirical formula which relates extent of adsorption. This is very important. Extent of adsorption that we are going to represent as x by m. I will tell what is that. Extent of adsorption with equilibrium pressure at constant, at this isotherm is at constant. What is constant? Temperature. This is the definition for Freundlich adsorption isotherm. What is that? An empirical formula which relates extent of adsorption with equilibrium pressure at constant temperature. Okay, so let me write that expression, that is x by m is equal to k into p to the power 1 by m. What is the relationship? Very important relationship this is. When they will ask the Freundlich adsorption isotherm, you have to write like this one, x by m is equal to kp to the power 1 by n. So what is x here? X, mass of, or you can say amount of adsorbate. What is the adsorbate here? That is nothing but gas. Say for example, what is m? So mass of adsorbent, that is usually the salt. Yes, are you getting? So what do you call that one? X by m is extent of adsorption. How much gas has been adsorbed on the particular unit mass of that what? Adsorbent. Right? So that is k, x by m is equal to k. And then if you take P, what is P? I told already in the, is this one, equilibrium pressure, right? So then A, K and N are constants. K and N are constants whose value changes with the particular temperature and pressure. So, if you take particular temperature and pressure, that is constant. But if you change the temperature and pressure, their value also changes. So, now this isotherm is the graph which helps us to know how much adsorption takes place by varying the pressure at constant temperature. So, if you want to study the variation of pressure, means the temperature should be constant. If you take both, then you cannot study well the effect of pressure. Okay. So, what he done by taking this equation, what he done? He plotted a graph by conducting the experiments. He plotted a graph where he has taken the extent of adsorption on the y-axis. Its extent of adsorption on the y-axis, and then the pressure at the x-axis, and he kept what? Temperature as constant at the constant temperature. So, he got a graph like this. First it was like this, then it has have a curve shape. Okay, and he divided this curve into three categories. So, that is, it is low pressure and it is high pressure, right? Are you getting? Very important concept. So, high pressure, and it is nothing but the intermediate, medium, or you can say intermediate pressure, right? If you look at the graph, so what you can see at low pressure, if you take, so what you can, this equation become x by m, okay, and you should know that this n is an integer, whose value ranges between, so let me see, whose value ranges between 0.1 to 0.5, 0.1 to 0.5. Right. So, at low pressure what happens? At low pressure the equation will become, the value of n will be very low. At low pressure the value of n is equal to 1. Okay. Suppose we were taking the value of so as 1 means what you can write? So, it is actually 1 to 5 in the textbook. Okay. So, at low pressure, so if value of n is equal to 1, what the equation will become? Kp to the power 1 by 1. So, because here n is equal to 1, then it will become x by m, 1 by 1 is k into p, or if you remove the right, x by m is equal to kp, or you can write this one as x by m directly proportional to p. What is the meaning of that? Extent of adsorption increases with increase in pressure and it decreases with decrease in pressure. That you can observe here. At low pressure there is a straight line. As the pressure increases, extent of adsorption also increases. Understood the concept? Very important this is. As the pressure increases, what? Extent of adsorption also increases. That's why we are going to get a what? A straight line here. Okay. So, now at the intermediate pressure, if you take this one, so at the intermediate pressure, so what you can have? So, if you take that this expression is there, no? It is well applicated for what? Intermediate pressure. It will be what? X by m is equal to k into the p to the power 1 by n. This is for what? Intermediate pressure. This is the expression you are going to get. Yes. What happens at high pressure? You look at the graph. At high pressure, so this is the low pressure, this is the high pressure, intermediate, this is the high pressure. You can see that there will be no change afterwards. So, there will be no change, you are going to get a straight line afterwards. Right. So, that means to say it has reached the saturation. We call that pressure as saturation pressure. What we call that one as? Saturation pressure. then the value of n will be infinity. The value of n will be infinity. Then it will become what? Kx by m. It is n is equal to 1. Yes, x by m is equal to Kp to the power 1 by infinity, because it has already reached the saturation. So what you can write? X by m is equal to K into the P to the power what? You are going to get independent of pressure it is, but because 1 by infinity is 0. So multiplied by that you are going to get what? So that is nothing but it is independent of pressure. So it will become 0, or you can say it will become a constant. That means to say, so what? Amount of adsorption, or you can say extent of adsorption. You have to note down here, extent of adsorption. So it is P to the power 0. Anything to the power 0 will be 1, right? 1 into K is nothing but K. Extent of adsorption is independent of what? Pressure. So we cannot apply what? Freundlich adsorption isotherm at higher pressure, because it is showing the value of infinity. That has counted, or that has became what? The limitation of this Freundlich adsorption isotherm. It cannot be applicable at what? You can say at higher temperature, because it leads to the saturation. What you call this saturation pressure means what? So rate of adsorption is equal to rate of desorption. So if you increase the temperature pressure further at constant temperature, no, increase the temperature, temperature is constant. If you increase the pressure further, no, you can see that there is a desorption, and rate of adsorption is equal to rate of desorption. We call that one as what? Saturation pressure. That happens at high pressure. Yes, very important concept. So at low pressure, extent of adsorption is directly proportional to the pressure. It increases with increase in pressure, it decreases with the decrease in pressure. That is the concept. At intermediate, we can well explain the what? Freundlich adsorption isotherm x by m is equal to Kp to the power 1 by n. That equation holds good perfectly at the intermediate pressure. And at high pressure, if you take, the value of n will be infinity. So it is independent of what? Pressure. So extent of adsorption is independent of pressure, and we cannot apply that equation at this place. So it can be well explained at low and intermediate pressure only. We cannot apply the Freundlich adsorption isotherm at what? The higher pressure. So, and one more thing, how to find out the value of n and all, or you can have one more concept here. So if you apply the logarithm to the what? This Freundlich adsorption isotherm, what is that? X by m is equal to, yes, what is that? Kp to the power 1 by n. By taking log on both sides. By taking log on both sides, so we get what that is? Log x by m is equal to, this is log mn form, right? Log k plus 1 by n into log p, right? So this is of the form y is equal to mx plus c. That is the equation for the straight line. Y is equal to mx plus c. So what is there in the place of y? Log x by m. What is there in the place of m? That is 1 by n. That is nothing but the slope. And what is there in the place of x? Log p. And what is c? Log k. That is nothing but the log k is nothing but the slope. So okay, so that is we are having. So that we can represent here. So slope is 1 by n. Slope is 1 by n, and log k is intercept. Okay, let me draw the graph now. How you are going to get? By applying the law. So what Freundlich done? No. So he taken log x by m on the y axis, and what I had to write? Log p on the x axis. What he got? Again he got a straight line. Then if you extrapolate this one, so you are going to get this. So you can get you are going to get a watch angle here. You can see this one, this is nothing but theta, or you can say the tan theta. So you can see that this is nothing but the what you can say log k. Log k, that is nothing but the intercept, isn't it? So intercept is equal to log k by comparing this one. And what is this? This is nothing but a, b. If you take, this is nothing but slope. Slope is nothing but 1 by n. That is nothing but here m. M is nothing but the slope. Yes. What is there in the place of m? 1 by n. So I can represent slope is equal to 1 by n. This is how you are going to draw the graph if you take once again logarithm on the Freundlich adsorption isotherm. So you have to take log x by m on the y-axis, log p on the x-axis. Here also you can see that as the pressure increases, the adsorption increases, and after that you can see that there will be a curvature here, there will be deviation. So that means to say that saturation has been reached. This is very important. This is the logarithmic form of Freundlich adsorption isotherm. It is generally the Freundlich adsorption isotherm. Okay, so this is the experimental result. Experimental isotherm always seem to applicable for the saturation. So that is. So how to identify this whether it is a chemisorption and or it is a physisorption depending upon the graph. That also you should know, because you are going to get the questions. So say if it is a chemisorption and you are taking extent of adsorption versus pressure, so it decreases with increase in pressure. I already explained this one. Yes, it decreases with increase in pressure. As the pressure increases, extent of adsorption decreases at constant temperature. That is a graphical representation of what? It is for physisorption. So if they give the graph, 4 graphs, and they will give the options for you, then you have to identify based on this one. Decreased. Again, if you take chemisorption, and if you take x by m on the y-axis and p on the x-axis, you can get it increases with increase in pressure, then it reaches the saturation level, and then it decreases. This is the bell-shaped curve what you are going to get for what? Chemisorption. By having the graphs also you can identify. This is for physisorption, this is for chemisorption. Okay, I hope you understood up to this. So I will continue after some time. Thank you.